as I have said in your handout for your assessment, these sort of questions you will be assessed on. Okay, so very switching on today, please, and following as best you can, and then you'll have your past HSC question to practice some more. Okay, now I won't make the one in your assessment overly difficult. There's a couple of ones here that are a bit long and a bit difficult. Alright, I'll keep it nice and simple for you, but yes, you need to be able to do these sort of things. Alright, so numerical and theoretical. And we're on the 29th. Tomorrow. Nice. Now on that actually, while we're on that, because it's Athletics Carnival tomorrow, on Friday, sorry, Friday, can we do a class tomorrow morning? Yeah, because I think this will be important obviously for your assessments coming up. I can't really afford to skip a class. If you are going to be at the Athletic Carnival on Friday, if you can get out of it, I'm not saying you can, alright, I'll be up in the clubhouse if you want to come bring maths work and do some work or ask questions. I'll certainly welcome you up there. Otherwise, if you're not going to be there, making sure you're spending that time getting the work done. Alright, question, example number 1. A, sorry.
Oh yeah, and Mr. Lee, do you know about our chemistry exam going over a maths class?
No, I don't.
When is it? Next week? 2 weeks.
She's made an exam.
Not the Monday, right?
Going to go into maths.
On the Monday?
On Friday.
Good.
Even though we have...
If it was Monday, someone would have lost their head, yeah. Alright, I'll wait till someone tells me about it. Okay, so you've all been given a CD?
Yes.
Because I want you to draw every single one of these diagrams. Okay.
That's a big circle.
Yep, and that's why you got big, everyone wants to do nice big circles, okay, so it's easier to construct.
Where are we going to fit the work? Underneath.
Okay, number 1. Right, so everyone has the question in front of them, I hope.
Do we have theory notes for this?
Hey, they're in theory notes, yep. Oh, and you'll need a ruler. Oh, everyone should have their rulers, right?
Yes.
Everybody?
I've already lost them.
You've already lost yours.
I've already lost it. I haven't lost mine.
Right, so you need a, not a ruler as such, but a straight edge.
Thank you. I don't see. When did you give us these notes? The
Hey?
notes on this. Did you have another book?
At the start of the topic. You got a ruler?
Oh, at the start with the circle.
Meta? You got a ruler? What happened to the one I gave you?
I know.
What is it? 9.7.
9.7
Oh, it's just here.
at the end of the...
Right here.
Hey, new assistant.
Yep, you're going. You're going.
They were talking about why would you not need an assistant?
Assistant admitter.
Okay.
Training up for like a week.
Alright. Yeah, I've got to work out what everything is near. Okay, so can everyone now draw the following? You can make it look slightly different to what's on the page for you. Right, so everyone should have the centre of the circle. So when you draw your circle, I want you to input the centre as well and the centre of the thingo. That's why you've got CDs. How useful are they going to be? Very. Alright. So the question says AB and DC are parallel chords. Now what I want you to do is I want you to make one chord longer than the other, but they're still parallel, okay? So one chord still longer than the other, but they're both still parallel. Okay. Right, so let's label it A, B, C, D. Right, so what we need to do is show that arc AD, so the arc over here, is equal to the arc on the right hand side, BC.
Yeah, I think we had a question like this.
Okay.
Do this? No way. No, I can't.
And you told us just to leave it because you had.
Alright, so we've got 8 questions. I'm intending on doing them today and tomorrow because I want you guys to actually think about what properties we might use, okay, to show that those two arcs are equal. Right, any ideas?
Can we bring the arc, like make it triangle to the center?
No,
Yes.
Because they're different sizes.
diagonal from
Yeah.
Yep, but Michaela's on the right track in terms of getting started. Right, so what I want everyone now to do is, mine can be a lot more fitty. Right, let's put the over to the centre.
No, yeah.
You would hope so. Alright, so it did not say anywhere in the question that the two chords are equally spaced apart. If they were, the question would be more straightforward, but you're not told that, therefore you cannot assume that. Okay, so let's put a O for the centre, because you'll also need to reference that as well.
Wouldn't it be the parallel? Wouldn't it say
No.
In the question, and also in the diagram in the notes.
yeah, no, but we're proving the arcs.
Yes.
If you have any circle
Oh, yeah, if you can prove us.
with two parallel lines,
No.
like two
No.
parallel lines,
The
the
different
arcs
lines
would be exactly the same no matter what.
No, but
I'm not saying the lines, I'm saying the arcs.
Yeah, but
What-
These ones here.
Yeah.
Yep.
And no matter what, where they are, as long as they're parallel, the two arcs will be the same.
Yes, so now we need.
Proof. Let's make a Robin's proof. There you go.
You actually have to prove it, you can't just word it.
and then he goes, and this is why you're wrong.
Alright, so what we need to do, okay, so we need to show that this arc here is equal to the length of this arc here. Alright, so if we call this X and Y, those angles there, because this is the very first property that we did. Okay, equal angle subtended at the centre will produce equal arcs at the circumference. So what we need to do is show that X equals Y pretty much. Okay, now they are not vertically opposite because these lines are not straight intersection line. Okay, now that was the assumption that may have been in the note because the question is a bit deceiving because the parallel lines look like they're evenly spaced. Okay, and when they put that diagonal in there AC, it looks like it goes through the centre of the circle. Okay, so that's why we're changing it up a bit. So, we need to show that what we are showing that X equals Y. When we show those are equal, we can then say the arcs are also equal from the very first property. Okay, so what I should have said there is let angle AOD. Every time you introduce letters in your diagram, you need to start it with your question. You're going to let these letters, this angle X represent this letter, and angle BOC equals Y. Now the other reason to do that as well is instead of writing all your angle symbol, right, we're just using letters, right, and then it's much easier to match letters up, okay, like term, as opposed to try and match your angles, okay. That will be the way to go. Right, Now I need everybody to put this diagonal in. So put the diagonal DB in. Now if you have different colours, alright, it's probably a good idea to include different colours in your diagrams, okay? And the diagonal DB is produced. Right, now the next property you need to, before we do that, anyone can see where to go next. Any ideas?
Oh, wait, shit.
We do A to C as well.
A?
We do A to C as well.
No, we don't need to.
No need?
Nope.
I usually go away.
Wait,
Angles.
wait, because the two sides of the triangle are equal because they're both radiuses, so can you figure out the triangle?
You could, however that's not where I was going. Alright, can everyone just draw a quick circle here? Right, centre point, 2 radii, sorry. And then chords to a common point. Okay, we all remember seeing this sort of thing?
Yeah.
Alright, so the centre, so the circumference angle is x, the centre is 2x. The angle at centre is double angle at circumference. Yeah. That's, that's the thing. So when I proved that, I showed you 3 different ways that could look. Alright, because it's the same here. Alright, so you go radius, alright, there's the common point B, chord there, and the second chord, which is the diagonal here. Alright, so.
And then that one equals 2x because...
Well,
okay. A.
that will be x and that will be 2x, alright? So let
And then which is...
angle AB, hang on, ABD, yep. Let's call it A. So again, from the centre, so it always has to be the angle at the centre. The centre, radius, chord from the end of the radius to a common point, alright? And we're going to call that angle A. Now can you also draw an arc just to that diagonal, because that's where the angle is. Alright. So that means that x is going to be 2 lots of A. Alright, so the angle at the centre is twice the angle formed at the circumference. Alright, so this reason, angle at centre is twice angle at circumference. So this is, most questions will require you to copy or trace the diagram into your book, because as you are proving it, you're also labelling your diagrams, okay? What you're doing there is you're making it much more easier for your marker to follow. They can see the evidence that you're making the connections on the diagram, okay? And if you don't get full, through the full proof, if you can get a pretty good diagram up there and getting started, you may get your part marks there. Okay?
Can you use these on the day?
I'll have to work that out. I don't know whether you're technically allowed those. All right? But we'll let you know next week. Okay? Right, so there's that one.
And BDC equals A.
Pardon?
Then we go BDC equals A.
Because...
Yes, all right. Yeah, we could do that. All right, so now we've got the other one here. So before we get to Robin's point, So we've got the radius, chord, and then that diagonal that we put in there. Alright? So that means this angle here, alright, from the base up to that diagonal that we put in.
Yeah.
Yep, alright.
We're going to call that A or B?
So we can call it A because we can prove that that's also the value for A.
So
Yeah.
Y equals 2A?
Guys, if you're not understanding, you need to stop me, okay? And we need to make sure that we are all following.
How's it done?
Alright, so angle BDC is also A because we were already told they're parallel. So using your alternate angles, alright, so we got that same value. So reason, alternate angles on parallel line are equal. Alright, so from the centre, we've got the radius there, the chord, and that diagonal from end of chord to chord. That means that whole angle is A, so therefore Y, the angle at the centre here, is double the angle at the circumference here.
And why couldn't we do like 4B and C?
So Y equals 2A. Alright, and your reason. Alright, so we got X is 2A, we also have Y is 2A. So matching our terms using elimination method of simultaneous equation, we therefore have X equals Y. Okay, so when X equals Y, okay, these two angles formed at the centre are equal, therefore they will subtend equal arcs at the circumference. So we need to state that. So therefore, arc AD equals arc BC. Alright, because equal angles subtend. Subtend means forms. Equal arcs. Okay?
That one actually wasn't that. I got that. I understood what we did there.
Most of your these sort of questions will not be too bad. Okay, it's just a matter of getting started.
Like most of them, you can do it.
Once you get started and you can get a couple of things, you're usually on your way to getting the full solution. Okay, it's just a matter of getting started. And also making sure you're setting out your proofs that are easy to follow. Right, any questions on that one? Okay, everyone's happy? Everyone's got some understanding on that? Right, let's try the next one. Right, B. Right, again, draw your circles using your disc. Right, so draw it accurately as you can.
We're doing the same, the triangle kind of thing.
Say it again.
So, hang on,
We're doing B, yeah.
yeah, triangle.
Okay,
Well, there's no room.
oh, that's where you got to lay it on the page with enough room.
Can I, I don't know, oh, you don't have enough page. I was gonna say, you got this, and you do the work.
Yeah, you can do that. We're going to do it down there. Smart thinking part.
Yeah, but you're on a different page to have them do the work.
What's that room to work in? You are aware.
As close as you can to parallel, yes.
If you say it's parallel, it's parallel. Okay? Like what? Parallel.
Oh, pretty close. Okay, so with a bit of practice, you'll get better at your drawings as well. Alright, so those two are parallel. Alright, it doesn't have to be exact, just get as close as you can, just don't make it look obvious that this line planting more this way, you know. So plan your work a bit if you can. Alright, like I said, you'll get better from experience. E, C, A. And we also have Q. P, and R. So they're giving you the pronumeral to use for the following angles. Okay, sometimes I'll do that, just makes it everyone's set in the same letters, so a bit easier to follow the process. And what are we asked to do? We're asked to show that if in the figure AB parallel to CD, we need to prove that AE, that whole top line, is equal to the length of the line BE at the bottom. Alright, thinking through the question, how are we going to justify that?
Huh. Let me think. I don't know. I do not know.
Alright, so we need to prove that AE is equal to BE. Talk to me, what can we do? Okay, so I want the big picture. How are we going to prove it? Not the specifics, but the big picture. So, no socket quad. Yep.
Well, both said it's a big isosceles triangle.
Good. Isosceles triangle. Alright, so we've got the big triangle here. So if we show that that triangle is isosceles, alright, we are then able to state that the two sides must be equal. Alright, so how am I going to show that these two triangles are isosceles? Where? Yep, okay, so P and Q. So basically what we're getting at is showing that P equals Q. Alright, when we do that, we can successfully finish our proof. Alright, so what's the first thing I can state? What properties from our congruent triangle, sorry, not congruent triangle, our circle geometry can we state and prove? What do we have in the diagram? We have parallel line.
Q equals R.
That was better.
Q
Hey?
equals R.
One actually helped me in this question.
You could be right.
Okay, we have parallel line. We also have what inside the circle?
Point,
What's it called inside the circle?
Co-interior feet, right there. So
Yep.
Q, sorry, right there. This bit's going to be 180 minus Q, and that's also going to be 180 minus P.
Yep.
So is that it?
That's one way to do it, but there's a much more simple way to do it. Okay. So, okay, Michaela, why did you say this was 180 minus P?
Because all opposite angles in the sides of quadrilateral are
What type of quad?
supplementary.
What type of quadrilateral?
Cyclic.
Cyclic quad. Okay. When you see a cyclic quad, about 9 times out of 10 you are going to use some form of property with a cyclic quad. Okay. Now, we can do it Michaela's way. We can go opposite angles of a cyclic quad are supplementary. So we can say this is 180, take away P. You can also use co-interior and do the same sort of thing, 180 take away Q, and yes, we can then go and prove it. Okay, but what's going to be a more straightforward way rather than do the little bit at the end there? Alright, what's this value R going to be in relation to P? Because? Exterior, okay? So P is going to equal R because you're exterior, so when you extend one of your sides of your quad, the interior opposite angle and the exterior angle are equal. Alright? So P is equal to R. So exterior angle result will be fine. Okay, so Michaela's on the right track in co-interior angle. Alright, but what's going to be much more straightforward? Because? Corresponding. Okay?
I've just down pack, you just haven't said anything. Doesn't do this work.
Okay, so that's what I'm saying. You spend the extra 15 to 20 seconds, even half a minute on a question, go through it in your mind, try and find simple ways to state results and to get your overall result. It can save you minutes in the end. Okay? Because the last thing you need to do is spend longer on a question than what you need to be spending on. Alright, so therefore, P equals Q. Okay, because we're setting the R's, because R is equal to P, R is also equal to Q. So by the transitive law, P must also equal Q. Right, which implies, so right arrow, means implies that triangle
Why does it implies arrow in the substitute arrow?
implies into.
Oh,
Right, so triangle AEB is isosceles. So therefore, AE is equal to BE. Reason, base, angles of isosceles triangle are equal.
so really, there's not much work into it.
Exactly,
You just have to
yes, and
find-
that's what I want you to get your head over, okay?
You just made it, when you said, oh, look
I
at
know.
that, deductive reasoning.
I know.
It was,
We're not there.
But because they won't always be this straightforward. Alright, like I said, there are a couple doozy questions in here.
easy.
Okay, everyone's following that one? Yep. Alright, let's try C.
That's mine.
Never mind.
No, it's not swap. Give him my five.
Alright, C. Something a bit more complicated there. Right, let's have a go at drawing it. Everybody.
At some point, it involved right angles.
Involved what?
A right angle.
Good.
Do you remember when we were doing polynomials? Do you remember in one of the test results? It had one of these in it. doing it now. Let's just throw a polynomial into it too.
You'll start to realise very soon, if you haven't already done so, there's often other topic areas that are related to answering questions that you need to answer right there.
You heard Matt Watts talking about his extension trees there.
Okay, so as best you can, let's draw it. Alright. So we've got the tangent at the bottom.
It's like your friends.
Your friends are my friends, Carl.
I know. I know. Which means you have no friends either. Oxley kids don't count. Don't say hey, you're one. Wait.
But how's everyone coping with the drawing?
Oh, drawing's fun.
Well, that's the easy bit.
Yeah.
I like doing it because I wouldn't do it.
Yeah, I do it. That's what I do.
I would draw the circles, I wouldn't do the work.
Yeah.
When I'm just getting used for intended. Maybe she's just putting that sort of
Alright, so we've got A, T, B, P, Q, D, M, and you are given the values of the polynomials here. So U, Z, X, and Y.
There's no one. Where is M?
M is the intersection of TD and PQ. Okay, so that's as it is in your notes.
You went through the center. You were meant to do it.
Right, so in the figure, so reading through the question, so in the figure ATB is a tangent at T. The bisectors of angle ATD and angle DTB cut the circle in P and Q respectively. Alright, so let's stop there for a moment. The bisectors, what does bisect mean?
Straight in the middle.
Cuts in half. Alright, so the bisectors of angle ATD is formed by the sum of U and Z. Right? And if they're exactly the same, therefore U must equal Z.
Oh!
Okay, so this is what you need to write as you're working through the question. Angle D, bisectors of angle DTB, the DTB. Okay, so the bisector is the line here, TQ, the chord. Alright, so therefore, if these two are cut in half, that we know that X must also equal Y. Alright, and that will go a long way to answering your question. Right. So, now we've done that, so we need to prove that first part, that PQ is the diameter of the circle. And once we've done that, we need to then show that PQ, that diameter, is perpendicular to that chord there.
Just see it.
Okay?
See it. So it's going to be Z plus X equals 90.
Pretty much.
I don't know how.
So
Right, so how are we going to do it?
it's because in the semicircle,
Alright, so part I, we need to prove that x plus z is 90. Alright, so when we show that it's a right angle here, the angle in a semicircle is 90 degrees. So we've got the triangle formed here. The angle in the semicircle is 90 degrees. That will make PQ the diameter. Okay, so how am I going to show it?
Well, all this stuff is, I know they can't. What?
all of them all together to equal 180.
Good. So let's start with that. Whoop. Alright, so we got u plus
45.
z plus x plus y must equal 180 degrees.
Well, if they're all equal.
Yeah, but doesn't, no, they're not all equal.
They're not all equal.
Two of them are equal to each
So we need to say angles on straight line are supplementary. So you will find in a fairly often in your proof, you're going to have 2-unit geometry stuff. Alright, so we're going to, we've covered that in 2-unit. Angles on straight line are supplementary. Alright, so we wanted to show that z plus x is 90. So we've got the z plus x here, but we also have u and y. So what did I do at the very start of the question?
So they were equal.
Okay, so we said that u is z and x equals y from the question. Alright, so 1 and 2.
No, no.
So from 1 and 2, we have z plus z plus x plus x. So I'm changing this u to a z, u equals z, and I'm changing the y, x equals y. Is equal to 180. So 2 lots of x plus z is equal to 180.
Whoa. Whoa.
So x plus z must be 90.
Whoa. That was whack.
Okay, so therefore angle PTQ is a right angle, okay, which implies that PQ is the diameter of the circle.
That one was big. That one was big. That's different.
Okay, and the reason, the angle in semicircle is 90 degrees. Okay. So you have 18 extension 1 properties involving circle geometry. Alright, you have all your 2-unit stuff, like your angles on parallel lines, you have your supplementary angles, okay, you have vertically opposite angles, okay, so all this geometry stuff will be used in this topic.
Yes, you did. You did choose this life, Robert. No, you did. You actually picked this class.
Alright, question. I'm going to fit it, yep. Alright, so double I. No, I'm not going to fit it. All right.
Yeah.
Part 2. Right, let's have a look.
Yeah, no, you would. Oh, unless you drew a contract.
Right, part 2. Focusing. Deep breaths. Right, so we need to show that PQ is perpendicular to TD. So we need to show that here is the right angle.
W equals Y. Where is this W? It's the angle QPT.
Is it PQ is perpendicular to DT?
Where's W?
Angle QPT.
So,
QPT. Angle,
So
angle
up at P,
QPT.
the angle at P.
Yeah, the
Oh,
angle
yeah,
P is
W.
meant to be a W.
And that equals Y.
TPQ is a W. It says it on
So
there.
up at P, that angle, the
oh, okay, yep. Cool.
That equals Y.
Alright, W.
You equal what?
And therefore, you can find out.
Because
That's,
of the in.
and then that one in the corner is supplementary to 90 and W.
Yeah.
Alright, so somebody said it. W is Y. Good.
No, not really.
Okay, so what's the big picture? What were we trying to get at?
If you find out that
Is you when the
Yeah, big picture. Big picture.
You gotta look outside of the circle.
Think outside the circle. Okay, the big picture is we want to show that the triangle. Sorry, it's some new software. We want to show that the triangle DMQ has the right angle on it. Okay? Yeah?
oh wait
Yep, some people have got some
W
thoughts going.
MD.
if you prove angle PMT is also a right angle,
Yep, you can do that.
and then it's
Vertically
opposite.
opposite.
Yeah.
And then you do that by Z 180 minus W minus Z.
Yeah.
Boom.
Yeah.
Along the lines of, yep.
Oh, I crumpled that. It was a good crack.
Alright.
That wasn't your bad one.
Alright, so I've set it out this way, so let's have a go at it here. You can do it your own method if you wish. Alright, so angle, so first thing,
Q is produced.
DQ is produced. Okay, so put in the diagram. Alright, so angle MDQ is going to be Y. Y. So Y is this angle here. Why is it Y?
Base angle of mass of
Nope.
No.
Yes, you're on the right track.
The triangle, the exterior angle.
Okay, what do we have here?
What's it called?
Tangent.
A tangent. Okay. When you have a tangent, I've told you this when we did the time. When you have a tangent and you have chords off that tangent, alright, you are definitely going to have, definitely more than likely, going to have a property where it's involved the angle between the chord and the tangent. Alright, so there's the chord, and there's the endpoint of the chord up to a common point. It is equal to the angle in the alternate segment.
Whoa.
Okay, so put simply, there's your circle, there's your tangent, there's your chord. Okay, so if the angle between here is x, for example, you pick another point on your circle, the end of your chords go to that common point, and that angle there will also be equal. Okay? Okay, you need to know this, which is probably the most frequently occurring extension 1 property that comes up. Okay? You'd be surprised how many times it comes up. Okay, so whenever you see tangent and you see chords, you are looking for this. Alright? So, here's the tangent, here's the chord. Okay, at the end point of the chord, you go up to that common point, D, so that angle here will equal that angle there. Alright? So angle between chord and tangent.
That's our reason for MD, Q equals NY.
Is equal to angle in tangent segment. So Kyle? So?
Oh, no, it's okay. Alright.
There's a shorter way to write that.
Yeah, no, that's
Alright, angle DQM is going to be Z. Why is it Z? Why is angle DQM? Why is the angle Z?
Butterfly wings.
Okay,
Butterfly wings.
good.
What about winging?
Alright, so we've got the two lines crossing over here and here. Therefore, the angles at the tips are equal. Alright?
This kid, I think he's from Bonnie Rig or something. He showed up, he looked at it. He was like,
He was Asian.
Oh, come on in. Come on.
I actually don't think he understood what was happening.
So back onto the butterfly wing. All right. So what can you tell me about any of the opposite angles of those wings?
W equals Y.
Good. All right. So these two angles will also be equal. All right. But we won't need that in our proof. All right. But I'm just telling you that's what it is. Okay. All right. We all following?
Yep.
Yes. All right. So I did that. All right. So that so angle in the same segment, standing on arc, same arc. Are equal. I'm pretty sure there's a more simple way to say that, but I've forgotten what it is. Okay, so in that triangle DNQ, so I'll state the value of these other two angles, and we want to then show that that angle there is going to be 90 degrees. Right, so implies the angle Q, what's that, D? DMQ going to be 180. Take away the sum Z. Take away the sum of the other two angles. Okay, so this is mathematics.
90.
There.
So it's 90. Yes.
So we need to show that this will give me 90. Alright, so let's state here, angle sum of triangle supplementary. Right, so this question is broken up into two parts, okay? The first part was to show that PQ was the diameter, Alright, and then the second part is to show that these two are perpendicular. Right, listening, everybody.
Yes.
When a question is broken up into parts like that, it is often that you are using the result of the previous part in your next section. Okay? So, from I, we had x plus z, was it? Yep. Was 90. Okay, that was the result that allowed us to prove that the P2 was the diameter. Okay, so from that, and so that means I've got the z, but I've got an x and I've got a y here. But we also stated at the very start that x equals y from the bisector information in the question. And x is equal to y from the start of the question. Okay, so therefore, angle DMQ is going to be 180, take away z plus, now I want to change the y to an x, because I have already stated that x plus z is 90 degrees. Okay, so equals 180, take away 90, which is 90 degrees. Right, does everyone follow what I've just done there?
Yeah.
Yep, so circle geometry is 1, perception of your geometry property, but 2, algebra, okay? Keep that in mind. So therefore, PQ is perpendicular to TD. Because we've shown that angle in that right angle, in that triangle is the right angle. When it's the right angle, those lines are perpendicular. Alright, so how are we all feeling?
I feel like I need another class. I feel like I need an apple. But maths, math class is pretty good. Yeah, no, yeah.
I think it's going to be okay if I have my proofs here with me.
Yeah, so that's why you need to be familiar with your proofs, your properties, as well as how to prove them, okay, so that we can do these. Now, tomorrow morning, 7:30, alright, to make up for Friday's class, can you all, for tomorrow morning, can you please draw the remaining 5 diagrams?
Yep. How many pages will we need? Two.
Alright, question D, you'll need 2 pages. 1 for the diagram, and you'll probably go over to a second page for your working. Everything else you should be able to get put down on 1 page. Okay, so you get the diagrams drawn, okay, that'll save us a bit of time and we can get through 5 on tomorrow. Okay? Okay, they don't have to be as big as the CD, okay, that was just something simple I could grab then. Alright, so you need to find something at home that you can draw a circle with. Okay, whether you have a compass or you've got some similar cup or something like that. Okay. CDs back on the rack there, please. Rulers on the next to it there too, or at the back desk.
Sir?
Yep.
Can I make another coffee, please?
Yep.